So today we were looking at limits and how to evaluate the limit. The only way to evaluate a limit without using a calculator is to plug in the value that x is approaching. So in this case, x is approaching 0. And so the only way that we can evaluate this limit is if we plug 0 into the equation. And if I plug 0 into the equation, I will have 1/5 minus 1/5 in the numerator, which is 0. Plug 0 in the denominator, it's 0. 0 divided by 0. That's undefined. That only means that the y value is undefined. The limit still exists. In fact, anytime you get 0 over 0, the limit is going to exist. The function value does not, but the limit will exist. So we looked at a few ways today in class, and we learned that we have to mess around with the function. So we have to somehow play around with 1 over 5 minus 1 over x plus 5 over x. We had 4 different ways, and a 5th way potentially to be able to mess around with this. In this case, we have fractions and fractions. Anytime you have fractions and fractions, the best thing to do is to simplify that. And so we want to try and make this thing just one big giant fraction instead of having fractions and fractions. So we're going to focus on the numerator and only the numerator. We still have a limit. So when we do the first step, the first thing we want to do is write that we're still taking the limit as x approaches 0. That is of huge importance that we make sure we keep limit there. We're not evaluating a limit right now, so it needs to be there. We're not going to mess with the denominator of x at all, and so we're going to go ahead and put that in there. But I'm going to mess with the numerator. So in the numerator we have 1/5 minus 1 over x plus 5. Let's get a common denominator. So the common denominator would be the product of our denominators. You can't just add x, that's not going to work. So our common denominator is going to be 5 times x plus 5. I wouldn't bother distributing that. It's not going to help you out at all. In fact, it's better to leave it just like that. And so both of our denominators will be 5 times x plus 5. In our numerator, in the first fraction, we would have to multiply numerator and denominator by x plus 5, so that's what we get in the numerator. In our other fraction, we would have to multiply numerator and denominator by 5, and so that's what we get there. So what does that accomplish for us? Well, in the numerator now we can go ahead and combine those fractions together. And so again, I'm not evaluating a limit yet, so I'm still writing that I'm taking the limit as x approaches 0. I am not going to write anything else. I'm going to continue to write that, until I actually plug in 0. So now I'm in the big giant fraction. We still have an x in the denominator. The two fractions in the numerator, when we combine those, we're going to have just one fraction left over now. The denominator is going to stay 5 times x plus 5, because that's what happens when you add fractions. That shouldn't be anything weird. In the numerator, we have x plus 5 minus 5. The two 5's reduce down to 0, and so all we have left is an x. Well, still, if we try to plug in 0, everything is nasty, and so we're going to go ahead and keep cleaning up this fraction. So we still have the limit as x approaches 0. I am not taking the limit yet, so I'm not plugging in 0 yet. When we have a fraction like this, we can write it out the long way. I'm not going to write it out the long way. I'm going to assume that you're okay with this. The way that you could write it is if you take that top fraction and then write the divided by symbol and then the other fraction, and then you would multiply by the reciprocal. This is what it ends up cleaning up to be. If this is confusing for you, you need to make sure and come in and see me so that you get this clarification. But all you're doing is just dividing two fractions. It works out like that. Now I just have one fraction, and these two x's here can be reduced. And so once we reduce those fractions, again, I'm not taking the limit yet, so I don't want to, I want to continue writing the word limit because I have not evaluated that yet. So we still have the limit as x approaches 0, but now those x's have reduced, so now we have 1 over 5 times x plus 5. Now we can go ahead and plug in the 0. I know I'm not going to get 0 divided by 0 because my numerator is just a 1 now, so my numerator is going to stay a 1. So now when I write this, I don't worry about writing the word limit because I'm actually evaluating the limit this time. When I plug 0 in, I get 1 over 5 times 0 plus 5, which works out to be 1/25. That is the limit as x approaches 0 of my original function, 1/5 minus 1 over x plus 5, all over x. The function value, however, f of 0, is still undefined. It does not exist. But remember, these are two separate questions. f of 0 means where is the black dot when we graph this? There is no black dot when we graph this because the function value doesn't exist. However, what is the limit as we get close to 0? If we looked at the table of values on your calculator, you would see that the limit is getting close to 1/25.